All right, thought it'd be worth to revisit this one more time in case that last one, the death was in the details there. So convert this into my auxiliary equation. So 3m squared plus 2m plus 1 equals 0. So we got m equal to -2 plus or minus the square root. 2 squared minus 4 times 3 times 1 all over 2 times 3. Okay, so that's -2 plus or minus 4 minus 12 over 6. So -2 plus or minus -8, which is going to give me a -1/3, plus or minus, that would be 2, so 2i square root 2 over 6, so -1/3 plus or minus I square root 2 over 3. Okay, so our general form then would be y equals e to the negative x over 3, c1 cosine of square root 2x over 3 plus c2 sine square root 2x over 3. And we don't have any initial conditions, so yay, that's good. Alright, so we like shortcuts in math, so once we can recognize special patterns, we can then jump quicker to the conclusion. So here are two special cases, two special patterns that if you see them, I'm going to walk you through how to find the solutions real quick, but make sure life a little bit easier if we can recognize them. So first off, they're very similar to each other. There's only a minus sign that's different between the two. So let's look at the positive one first. So y double plus k squared y equals 0. So my auxiliary equation would be m squared plus k squared equals 0, which means my solution would look like plus or minus ki. Okay, so that then tells us that our general solution, since we're dealing with imaginaries, would be c1 cosine kx plus c2 sine kx. Okay, that's nice. This other one, we're gonna give me a second. Give me a minute here to walk you through the logic on the other case. But let's take a look at the other one. So y double minus k squared y equals 0. So our auxiliary would be m squared minus k squared equals 0. So that means m is equal to plus or minus k. Okay, so that means our general solution looks like y equals c1 e to the kx plus c2 e to the negative kx. Okay. Oops, sorry, hold on. Now, we're going to make a connecting assumption here, so it's going to give us a similar form, which is the whole reason why we're having this interesting conversation. So let's start with the idea that what if I let C1 be equal to C2, and specifically I let them equal to 1/2. Right? So what does that tell us? That says that I have 1/2 e to the kx plus 1/2 e to the negative kx. And if I factor the 1/2 out, That's e to the kx plus e to the negative kx, right? But that is the definition of hyperbolic cosine. So that's cosh. I'm going somewhere with this, so just give me another 30 seconds here. All right, so what if I let C1 equal to C2 equal to negative 1/2? All right, what's that going to do for us? That's going to essentially give us negative 1/2 e to the kx minus, sorry, I'm checking my notes over. My conditional assumptions were off. The C1 we're going to say is positive 1/2, and C2 we're going to say is negative 1/2, which would give me 1/2. Factor that out, so e to the kx, and that would put a minus in there, so e to the negative kx, which is the definition of hyperbolic sine. Okay, so what does that mean? That means if I'm dealing with this second special case, and the reason why we care is there's some similarity between how the solutions work out, I can justify that this is a form of cosh and synth. So our final answer looks something like C1 cosh kx plus C2 synth kx.